Hello guys, I'm back with another video. So I've got several transmitters here, as you can see. In this video we're going to be focusing on this transmitter, the GD-2007. Okay. In the next video I will be testing those two guys. Well, anyway, so as you guys probably know, if you've been watching my channel for a while, I've already tested this transmitter, okay? But this is actually the new version of this transmitter. See, I made a video in the past. If you're watching this and you haven't seen that video, you should go back and watch it. Okay, because it is a review of this, well, not exactly this transmitter, but the old version of this transmitter. And honestly, that transmitter put out the worst spectrum that I've ever seen. I've never seen a worse, transmitter spectrum. All right. Well, see, the company, got back to me and they were very apologetic. And they said that they would work on, improving the transmitter. They did blame me to some extent in regards to my power supply, but it's definitely not that. I was using a very good PC power supply. I mean, it's not quite as high-end as a Meanwell power supply, but, it's for mini PCs, so it's got a pretty clean output. And so that wasn't the issue. But their previous version of this red transmitter put out a very bad spectrum. And so they sent me here a new version of it. Okay, so it looks, nearly identical, but it is not. Okay, so this is a new version of the same transmitter. And so I'm going to be testing this to see, if they improved on the spectral purity, how pure it is, and yeah, if this transmitter is any good, we'll find out. Alright, so I just powered it on before starting the video. As you can see, we've got 8.6 watts and 87.0. So let's check out the burn meter. I've got a 50 watt element here in bird. And what do we have? Alright, we have just a little bit over 6 watts is what it looks like. So we're using the middle scale, okay, the scale where it ends at 50 on the right hand side. And so you can see there's the number 10 there on the left. And so if you look at that, you can see that we've got just a hair over 6 watts, okay, which is pretty much exactly like it was before. I remember how when I had it set to about 8 watts, it was putting out about 6, right? And that's about the same. So that hasn't changed. But that doesn't really matter. That I don't mind having a little bit less power than they say, because the way RF works, it's not linear in terms of the signal intensity. It's exponential. So 2 less watts is not really that big of a deal, okay? But what does matter is the spectral purity. Because, see, if you haven't seen the previous video that I did, this transmitter was actually putting out interference in the aircraft band, okay, which is one of the worst possible things that could be happening, right? And so I'm going to be determining if we're going to still have that problem, okay? So here's the spectrum, and you can see I've got it showing both the fundamental and the harmonic, okay? And so the harmonic is not fantastic, but it's not super bad. You can see I've got the marker on the harmonic right now, okay? And as you can see, it says negative 41. Now, I really wish I could get this spectrum analyzer to do DBCs, like decibels below carrier, but it doesn't do that for me automatically. So you just kind of have to do it in your head, okay? So what it is if we take a look up here, I don't know if you can see this, but the fundamental carrier is at negative 4 right now, okay? And our harmonic is negative 41, okay? So that means, I believe, so it's 4 decibels worse than this, okay? It's 4 decibels worse than that. So, yeah, so I mean, it's you know, it's not horrible. I'd say it's definitely an acceptable harmonic, although it could be a fair bit better. Okay. But, you know, harmonics are something that, if they really matter a lot to you, you can always add another low-pass filter if necessary. So we're not going to focus too much on that. I would say that's not too bad. So what I really want to see here is how bad the carrier is close into the carrier, because that's the issue that we were having before. So, oh, and by the way, I should mention, I am not seeing any aircraft band interference, which is a great thing, okay? You know, because before we had this big chunk going up right on top of the aircraft band, right? And we're not seeing that now. So that's great. So let us do this. We're going to zoom in here on the carrier. So I'm spanning in. Uh-oh. I'm already seeing something that does not look the greatest. You guys see that? See how much this is spreading here like this? That does not look good. But let's keep going in. Yeah, alright. Well. Wow. Alright. Well. Okay. So here's the thing. Here's the thing. I would say that, okay, this is the typical BH chip porcupine. Okay, this is the porcupine that the BH chip puts out. They all do this, although this looks especially bad. One thing I can say, though, that has improved is that the carrier and these other things are stable. You know, it's like they're not wiggling around like they were before. So that is a good sign. That is a good sign. But I do not like this porcupine thing, right? But we shall see. You know, if I turn the stereo off, we shouldn't have any of this. All right. So, let's see what we have in the menu. Let's see if I can get a good view here. All right. So we got our power. We've got frequency. We've got stereo. We've got preamp. We've got input. We've got volume, microphone, MP. I believe that's the MPX volume. RF. All right. Temperature and SWR. Yep. And then we're back at the beginning. Okay. So we'll leave the power. Let us, yes, right here. Let's change this to mono. Alright, so we're now in mono. Alright. So everything else should be the same, but we're in mono mode now. SWR is good. Alright, so let's look at our power. And yeah, we got just a little bit of droop in power, but you know, like only like 1/10 of a watt or something like that. So we're putting out a solid 6 watts, which is good. Alright. Well, as you can see, you know, it's like the big porcupine thing went away, which is nice. This is not ideal, right? But it's not nearly as bad as before. So the the heat just went on. Hopefully you can still hear me. But you know, this is not ideal. Although it is, I gotta hand it to him. It is way better than before. This is much better than before, but this still does not look very good. Let me just span in a little more. Yeah. See, we've got this. That shouldn't be there. You know, we shouldn't be having that junk. But, you know, it's not that high up, right? It is not that high up, so am I going to complain? It's like, it's, you know, as you can see, the frequency still is not that stable. As you can see, the carrier is moving around slightly. So it's like, they did improve things. They definitely improved things, but I would say it's still not ideal. All right, let's see what else we can do here. All right, so we've got input setting, we've got line, what else do we have? MPX. Okay, let's change it to MPX. Did that improve anything? Nope. Same thing. Okay. Right, and I think we tried this before as well. We tried lowering this all the way, thinking that maybe the volume of this was, you know, creating some kind of interference or something. You know, so I'll turn that down. That's the lowest it goes to. I'll also do it with this one as well, because we're not going to use any microphone. We're definitely not using a microphone. All right, down to 17. Yep, and that's it. So yeah, I don't know. You know, it's like, I'd say this is right on the borderline of me saying, like, okay, this is acceptable versus not acceptable. You know what I mean? That's why I'm kind of hesitant to really comment too much on this, because it's like, yeah, I suppose it is acceptable, but it isn't ideal. Yeah, we're zooming out here, zooming out, zooming out. Zoom in. And there is our harmonic again. You know, so, you know, there's the one harmonic, there's nothing else, you know, which I would say is pretty solid. You know, so it's like, this is a huge improvement over the last one, but I still cannot say that I quite recommend it. However, there is a big advantage in having MPX input, but I have a potential upcoming video, guys, that I discovered a way to make a very cheap and relatively powerful, about 30 to 40 watt, MPX capable transmitter just from Chinese transmitter boards. I discovered something very interesting, and I may actually have it. Yeah, here it is. I'll just show you right here. So there's this. I found this on AliExpress, okay? And this is something that I am very excited about for a future video at some point. This is the MB1504, I believe. The MB1504, or maybe the MB1501. I'll definitely put a text overlay in the video here when I discover exactly what it is. But essentially what it is it's a real PLL VCO. So this is an FM PLL VCO board, right? So on this little board is a real PLL and VCO, and it operates in the FM broadcast band, right? And so it's got a little screen up here. If you can see, this is a little OLED screen, and it's got, you know, some buttons here, some nice push buttons, and it's got a little SMA connector, and it's powered via 5-volt USB. Right? And so this is a real PLL VCO, meaning that it just has, I don't know if you can see it, but it just has one audio jack somewhere. I don't know where it is, but it's got a little 3.5 millimeter audio jack on the back somewhere. And so essentially, you've got an MPX, a fully MPX capable transmitter, by using this, right? And it should output a very clean signal because it's not using any of these, you know, all-in-one integrated circuit type transmitter, you know, like the BH chip or whatnot, right? It's not using any of those things. This is a real PLL VCO, right? So it puts out a very low output though, you know, like 1 to 10 milliwatts. And so what I thought the perfect thing would be to do, to couple it with this thing. So this is a 30 to 40 watt amplifier board that has many stages of amplification. So it takes an input of only about 1 to 10 milliwatts in, right? Which is exactly what that little VCO board produces, right? So this amp would be the perfect thing. It would be the perfect thing to use towards, you know, having a transmitter that's MPX capable. And I'm not sure what that junk is on there. It looks like somebody spilled something on there. That wasn't there before. I don't know how that got there. But anyway, this is a really nice little amplifier board. And I think coupling it with that VCO would be brilliant. So anyway, that's for a future thing. But let me get back to what I was doing here. So we've got this transmitter. I'm going to just do a test by changing the frequency here. Let's do a test at the high end of the band. Yeah, let's do 107.9. That's the high end of the band here in America. Alright, so that should pretty much be it, I think. Oh yeah, we've got a... Yeah, so every time you change the frequency, you have to reset the power output. You have to do that yourself. So I'm doing that here. Oh, wow. Okay, it goes all the way up to... Oh, interesting. 10 watts? Yeah. Almost 10 watts. That's pretty good. Okay, so now it says we've got 10 watts at 107.9. Let's see what we're getting here. Okay, yeah, that's pretty solid, but we're not getting 10 watts. We're getting a little above 8 watts. A little above 8. Which actually is, I think, very reasonable because this transmitter is meant to be a 7-watt transmitter, right? It's meant to be 7 watts, so it's putting out 8 watts, right? So I think they should just honestly change this to say what it really is. You know, it's like, don't lie. Say what it really is. It's 7 watts, right? You know, or 8 watts. Yeah, no, it's 8 watts. Yeah, it's 8 watts. But anyway, so let's look here. Yeah, so it's actually doing a really good job at the high end of the band. That's one good thing I can say, is that it's definitely putting out at least, if not even more power than it was putting out at the low end of the band. Okay? Now, I might have messed up. I'll check that again, because I think it's possible I didn't have it set all the way to the highest power when I had it on 87. But anyways, let's just check here and see if we've got a harmonic. Oh, wow, nice. Very nice. So we've got no harmonic to speak of at the high end of the band, which is great. So that's really good. Let's do a peak CF, and then let's span in. And let's just see if we have the same kind of spectral purity going on as we did before. And peak CF again. All right, continue spanning. Oh, I think it's a little better, is it? Yeah. Yes, it is. Yeah, so as you can see, this is a fair bit better. We're not seeing those spikes on either side here. Oh, it is kind of jumping around, though. Oh, yeah. What? Why is it doing that? You know what I'm really going to have to do for you guys? I'm going to have to actually take a listen to what this thing sounds like. Because, see, this carrier is really moving around a fair amount. You know, and I'm thinking that must be producing some kind of noise. However, you know, the close-in spurs, that aspect of things is much better. You see, I believe I was zoomed in about this much when I was at the low end of the band, okay? And as you can see, there's no weird spikes over here like there were before. So it seems to actually have a little bit better performance when you're using it at the high end, all the way at 108 or 107.9, you know, same thing. However, I do notice the carrier kind of bumping around. When you get really close in, you can see it moving around. And that's pretty disconcerting. That's definitely disconcerting. However, I'm going to do this first. I'm going to go back to, let's go back to the low end again. And it was 87.0 before, but I'm going to do 87.9 because that's what I always do. It's just that it shipped with it set to 87.0. So we're doing 87.9, and I'm going to up the power all the way. And let's just check again. I just want to be sure that maybe with it set to 87.9 and with the power all the way, maybe it'll be a little different. Ah, okay, yeah, no, it isn't going up as much. Just trying to make sure that it's not just this weird, you know, because this thing sometimes doesn't register. Yeah, no, it's not going up any more than that. Okay, so that's the full power. That's all we're going to get. So let's take a look over here. Yeah, so 5.5 watts. 5.5 watts. Okay. Yeah, it seems to be drooping a little bit now that it has warmed up. It's not producing quite as much power. But it's pretty clear that this transmitter actually does better. That this, excuse me, I'm having trouble using this thing. That this transmitter does actually work better at the high end of the band. So let's go down here and try to find the carrier. There it is. Okay, so we've got the carrier back on the screen. All right, so now let's span in on the carrier. Okay. I see. Yeah, so it's... Yeah, you can see those little things there, but they're pretty small. It's not too bad. Let's keep zooming in. Yeah, so see, the only thing I'm really concerned about here is how every now and again I'm seeing the carrier bumping around. I'm seeing it move. And it's like, yeah, see that? It should not be moving at all. It shouldn't be doing anything because I have no audio going into this whatsoever. So what I'd really like to do is take a listen to the actual audio that, like, what does it sound like over the air? I want to hear, is it just silent or is there some noise? I'm going to try to do that for you. Can I do that on video? I'm trying to think. Okay, so I have this radio here going. And I don't know if you can hear it. You hear that? Hear it? It's not too bad. Okay, it's not too bad. But here we are, 87.9 with wide FM. Alright, and that's what we got. 87.9. Okay, and so yeah, you can hear a little bit of hiss in the audio. Alright, and by the way, there's a station on 88.5 and I can't tune to it with one hand, but when I tune to it, I notice that if I get close to this transmitter, the station goes away. I can only receive the station if I back up really far, like back here, then I can receive it. So it's clear that some of the junk in the signal from this is blocking out that other station, okay? However, you know, that is to be expected. You know, if you're like standing right next to a pretty high-powered transmitter, you're going to have some station blocking even with a really good transmitter, okay? However, this is fully into a dummy load. You know, I should repeat that. This transmitter is fully in a dummy load. It is not hooked up to any kind of transmission system or antenna or anything, right? Because I don't do that here, right? It's like that's, you know, this is for testing transmitters. This isn't about actually broadcasting a signal, right? And so given that it's going into a dummy load, I am kind of surprised that it is still blocking out that other station. That is not so great, because the amount of power that's actually leaking out of the dummy load is very low. So if this transmitter were to actually be transmitting over the air, it may actually block things out much worse. So yeah, anyway, I just felt like, you know, I should give it an actual try and let you guys listen. You can hear some hiss. But yeah, the volume is decently high, so with the volume set low enough, you probably won't notice it. So anyways, I think that pretty much will conclude this video of this transmitter. I don't know, what do I rate it? You know, it's like, I guess I'd probably give it a 5 out of 10. I give it a 5 out of, well, I give it a 5.5 out of 10, okay? Because even though, yes, this transmitter is very run-of-the-mill in terms of its spectrum, in terms of, you know, what its capabilities are and all of that, the reason why I give it 5.5 is simply because it does have MPX input. So for that very reason, I'll give it an extra half a point. I give it 5.5. All right, so it's definitely an improvement over the old transmitter of this type. You know, that I'd honestly give a 1 or like a 0, right? Because it was interfering with the aircraft band. So it's clear that they fixed that. You know, it is no longer interfering with the aircraft band. You know, I'll span out and just check one last time to be sure it's not putting out anything weird. You know, it's been running for quite some time at this point, so, you know, if it's putting out anything, we'd probably see it at this point. So let's keep zooming out here until we see the harmonic. And there it is. And actually, it looks a little, honestly, it looks smaller. Yeah, that's so weird. It is smaller. What? No, it's definitely smaller. You guys remember, right? At the beginning of this video, the harmonic was like... What? No way. Because see, I'd say that's probably like, what? Like 48 or 50? It's like negative 48 or 50. And before, it was negative 41. It has definitely gone down. And it's so strange because, like, I have the thing set up. The only difference is that it was on 87.0 instead of 87.9 before. So I guess let's just try that. We'll put it back on 87.0. I don't want to make this video so long, guys, but, like, you know, inconsistencies like that are things that really bug me. You know, it's like if it's going to be different each time, that's a very important thing to note. You know, it's like, maybe it just wasn't putting out the full power. that it was capable of. Because see, now we have 8.5 and 87.0. Yeah, so now we have 6 watts. So I think it was set just slightly low. And I think what the issue is that this rotary encoder is very finicky, right? So you really have to turn it very quickly to get it to actually reach the true maximum point, the true maximum power. So I think it might not have been set. Let's see here. Yeah, that's closer. That's closer to what it was before, but it's still a little less. It's still a little less. That's so weird. Well, I mean, that's a great thing. I'm glad. Yeah. So anyway, well, that concludes the video of this transmitter. You know, it does claim to have an MPX input, but that's something that I'm kind of skeptical of, given that, you know, there are no other Chinese transmitters that have that capability. Yeah, and then also the fact that I know this transmitter does have a BH chip inside of it, so I'm not sure. So it'd be interesting to try out the MPX input. Other than that, I'm going to conclude this by saying that they definitely made a huge improvement. So China Broadcast, thank you guys for, you know, getting back to me and making such a big improvement on this transmitter. You know, it's like I really appreciate that. Although I gotta say that improvements can still be made. It's clear that this transmitter still could be even better, and I'm hoping that your engineers will continue to make it even better. Because, like, I'd love to see it such that close in to the carrier, that it has less noise around the carrier. That would be good. So yeah, so that pretty much concludes this video. Alright, thanks for watching, guys. Take care.